Assalamualaikum. My name is Muhammad Shamil. I will talk about the introduction and the objective. But first, we look at the introduction. Air conditioners and refrigerators work the same way. Instead of cooling just the small, insulated space inside of a refrigerator, an air conditioner cool a room, a whole house, and an entire business. Air conditioner use chemical that easily convert from a gas to a liquid and back again. This chemical is used to transfer heat from the air inside of a home to the outside.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Alif bin Muhammad Rani. Inshallah, we'll continue with the literature review for the air conditioning system. For the basic air conditioning system, the machine has four main parts, which are compressor, condenser, evaporator, and the expansion valve. The compressor and condenser are usually located on the outside of the air portion of the air conditioner, and the evaporator is located on the inside of the house, sometimes as part of a furnace. Okay, now let's continue the workflow for the air conditioning system. Okay, for the first step, the compressor will continually forces more and more of the refrigerant in gas form into the condenser, and as it does that, the particles of the gas are forced to move closer to each other until it condenses into a liquid. This is called a phase change. Hence, the use of the term phase change to describe the technology. During the compression process, heat is radiated from the refrigerant by the condenser coil and the fins attached to it, which make it easier for the air to absorb heat from the refrigerant. That helps to condense the refrigerant because cooler gases condense more easily. The condenser fan accelerates the cooling process by passing cool air over the condenser coils because cooler air is capable of absorbing more heat than hot air. As the particles of the refrigerant gas move closer to each other, that causes the refrigerant to release heat. And for the second step, after it being condensed in the condenser, the compressor still forces refrigerant into it continuously, and that forces it out of the condenser through what is called the capillary tube. The capillary tube is a very narrow tube which leads into the evaporator and restricts the flow of refrigerant. As refrigerant enters the evaporator, which is under low pressure due to the fact that the compressor is sucking from it, the refrigerant evaporates in it very quickly, and that evaporation process causes the refrigerant to absorb heat. The faster it evaporates, the colder it becomes. This is the second phase change that takes place in air conditioners and refrigerators utilizing the vapor compression cycle. The cool refrigerant gas then absorbs heat from the evaporator coils because the gas is cool, and it enters the compressor afterwards, still cool, and absorbs heat from the compressor, cooling it and extending its life. The evaporator or blower fan draws air from the room and blows it over the coil evaporator, which cools it, and then the step 1 is repeated. And that's all from me. Thank you.
Thank you for the previous presenter. My name is Dendi Sirin, metric ID MA18144. I will be presenting for the next part, which is the experiment setup. This is the model that we use for the lab, which is model AC1 Soltec air conditioning, which is shown in this diagram. And this is the component for the air conditioning unit, such as control panel, expansion valve, orifice, preheater, DP transmitter, heater, and others. Moving on, here's are the air conditioning unit that we use in the lab. Next is the process schematic diagram for the air conditioning unit, which is shown in the diagram. It consists of different components such as the combined temperature or relative humidity transmitter, radial fan, steam humidifier, preheater, evaporator, reheater, and orifice. After that, we move on into refrigeration units. As you can see on the diagram, the components listed are the compressor, condenser, expansion valve, and evaporator. Moving on onto the experimental procedure. The first procedure is the general startup procedure. First of all, we need to make sure that the units are in good and proper condition by doing a quick inspection. After that, make sure that the tap water source and the humidifier water supply are connected properly. And then the drain hose must be connected to the condensate collector at the bottom of the air duct. Finally, we turn on the power supply switch and also the main power switch for the air. Next is the procedure. First, we need to turn on the radial fan and set the air velocity at 15% of the maximum airspeed. And then turn on the refrigeration unit and then allow the system to reach steady state approximately in 15 minutes. After that, we record the temperature of the refrigeration circuit. And for the refrigerant flow rate, we need to obtain it from the refrigerant flow meter. Finally, is the general shutdown procedure. We need to turn off the preheaters and reheaters by allowing it to cool down with the fan on. After that, the fan speed control knob are turned off, followed by the fan switch. And then ensure that all these switches are turned off from the control panel. And then main switch and power supply are turned off. And finally, the tap water supply is closed. That's all for me. Moving on onto the next presenter.
Now we continue for the results and calculation for air conditioning lab. There is table 1 and table 2, which is table 1, relative humidity and air temperature, and table 2, refrigerant pressure and refrigerant temperature. For each of these post table, we choose preheater and reheater of 1 kilowatt because it is the most suitable for human comfort condition, and the constant fan speed is set at 60%. And next is the results of the refrigerator system. So firstly is the refrigerant temperature at point 1, which is 70.06 Celsius. Next is at temperature at point 2, which is 27.97 Celsius. At point 3, 24.86 degrees Celsius, and at point 4, 8.92 degrees Celsius. And next is it is for the refrigerant pressure. At point 1 and 4, it is 6.75 bar. At point 2 and 3, 10.95 bar. And next is the refrigerant flow rate. We got 8,402.4 liter per minute. And the refrigerant enthalpy at point 1, 326.147 kJ per kilogram. Next at point 2, 9.872 kJ per kilogram. And lastly at point 3 and 4, 167.980 kJ per kilogram. And next is the refrigerant specific volume. We got 0.778 meter cube per kilogram. And refrigerant mass flow rate, we got 0.18 kilogram per second. And lastly, the refrigerant output, we got 24.47 kilowatt. And that's all from me.
I will continue the results and calculation. Compressor performance output. First, we calculate the actual compressor work. we use this formula. We got the data from the Google Classroom, and then we use the formula to calculate the actual compressor work. We got negative 316.275. Then we use this formula to calculate the actual coefficient of performance, and we got negative 0.5. Next, we calculate the theoretical compressor work. We got negative 316.275, equal to same with actual compressor work. And also, and next we calculate the theoretical coefficient of performance. We got negative 0.5. Next, we calculate the effective power factor. We use this formula and the mechanical coefficient of pressure. Then we got the answer equal to 800. For the theoretical compressor output, we got a negative 56.930. Next, we calculate the internal compression output, and we got the same answer with theoretical compressor output. We use same formula, and we got negative 56.930. And lastly, we calculate the compressor drive coupling power. We got 71.1618.
Thank you.
Warahmatullahi wabarakatuh, and hello, my name is Muhammad Ahmad Amir Muhammad Kamuzaman, metric number M8171. I'm gonna do the part of discussion. Question 1. Briefly explain how a condenser, compressor, expansion valve, and evaporator work. Condenser. The condenser is equipped with a fan that cools the high pressure gas and convert it back to the liquid. Compressor. The compressor's primary function is to convert low pressure gas into a high pressure gas at a high temperature. Expansion valve. The expansion valve relieves pressure on the liquid refrigerant in the evaporator, allowing it to expand or change state from the liquid to vapor. Then the last evaporator, this section of the air conditioning system receives the high pressure gas that is now transformed into a low pressure liquid, the working fluid that emerges as a gas from the evaporator ready to be compressed by the compressor once more. Second, based on your experiment, sketch the basic refrigeration cycle and plot the point on pH diagram to obtain a complete cycle of the process. This is the basic refrigeration cycle, which is expansion, evaporator, compressor, and condenser. And next to it is the pH diagram, which is recorded for pressure by enthalpy. Third, determine the corresponding enthalpy and mass density from the pH diagram and calculate the evaporator cooling refrigeration effect. Since the rate of heat absorption of evaporating cooling occur at low state, the corresponding enthalpy are at state 1 and 4. The lower the temperature of the superheated gases entering the compressor cylinder, the denser they are. This is how we calculate the refrigeration effect. Compare the value of coefficient of performance of refrigerant between experimental result and theoretical. Based on calculation, explain in your own words but why the different results occur. The experimental and theoretical value of the refrigerant's coefficient of performance are quite different. Because of a parallel error in taking reading during the experiment, our actual COP value is outside the range of the stand of COP. Most refrigerants currently in operation are either based on a vapor compression or on an absorption cycle. Could you please explain what is the difference between vapor compression and absorption cycle? For vapor compression, use HCFC or HFC as refrigerant, while absorption cycle use ammonia or water as refrigerant. Then compression is done mechanically with moving part for vapor compression, and compression is done chemically for absorption cycle. High coefficient of performance for the vapor compression, while low coefficient of performance for the absorption cycle. And the last, it is less bulky for vapor compression and it's bulky for absorption cycle. What happened to the coefficient of performance of refrigeration system if refrigerant temperature that came out of compressor enhanced from phase 1 to 2 is compression process? As the temperature at exit of compressor increase, H2 will increase, which will increase the work input to the compressor. Hence, as work input increase, the COP of refrigerant will decrease. Hence, as T2 is increased, the work input will increase, and that will reduce the COP of refrigerant.
Assalamu alaikum, I hope everyone is doing well. My name is Amar Ali bin Hammam, and in this presentation my part is going to be the conclusion, so let's get straight into it. The first type of system, heating and air conditioning split system, is a split system. It got an outdoor unit containing the condenser and compressor, and an indoor unit containing the evaporator, coil, and blower. The second type of system, hybrid pump heat system, is a heat pump which is utilized in conjunction with a furnace that flares natural gas, fuel oil, or propane. The third type of system, ductless mini-split head pump system, provides a solution for spaces where conventional ducted systems are not compatible. The fourth type of systems, packaged HVAC system, contains the compressor, condenser, and evaporator all in one unit, often located on the roof or near the foundation. HVAC is a very significant necessity in everyone's life because it helps keep you comfortable with air conditioning during the warm weather and heat during the cold weather. The split system is the most generally used, but hybrids are on the rise due to their energy efficiency. Many split systems are perfect for picky families or service industry, and packaged heating is perfect for small places or warm climates. As a conclusion, the recirculating air conditioning unit can be used to illustrate and evaluate almost all of the processes covered in practical air conditioning plant, just like heating, cooling, humidification, dehumidification air stream. Sometimes two or more of these processes are used to bring air to a desired temperature and humidity level. Different air conditioning processes in psychrometric chart. Notice that simple heating and cooling processes pop up as horizontal line on this chart, since moisture content of the air stays constant in this process. Air is mostly heated and humidified in winter and cooled and dehumidified in summer. That's all we have in our presentation. Thank you so much.